All right, you crazy kids, here's your lecture on polyatomic ions. By definition, a polyatomic ion is a covalently bonded set of two or more atoms that have a charge. Okay, so we have two things going on here. We have covalent, which means you're sharing electron pairs, but you also have charge, which means it's either going to be a cation or an anion. In reality, polyatomic ions are a combination of both. So they are things that are covalently bonded that have a charge, so they act ionically. They happen at the same time. A list of the common polyatomic ions we're going to be using is in Table B in your packet. Take a look at them. I would become very familiar with them, know them by sight. You don't have to memorize them. You have access to that packet whenever you want, but it's certainly going to help you out. We use these all year long. For instance, sulfate, you should just be able to recognize that's a polyatomic ion. So I'm familiar with the word enough that I know what it is. I can look it up. I have it memorized, but you don't have to. It's SO4 2 negative. That means the sulfur and the oxygen are covalently bonded together, but they also have a charge. So this is covalent and ionic at the same time. Kind of cool. OH negative. OH negative, by definition, is hydroxide. That means the oxygen and the hydrogen are covalently bonded. They're sharing electron pairs, but they've also gained an electron. All right, and it's very unique. These could be positive, they could be negative. Take a look at that list. You don't have to make flashcards of them. You can if you want to. You'll never have to, produce them from memory, but being able to recognize them by sight will certainly help you out along the way. For instance, this thing right here, I know it has a polyatomic ion because I know OH is a polyatomic ion. If I look at it a little bit deeper, I'll realize that sodium has lost an electron, and OH has gained that electron. So I have a positive-negative cation polyatomic ion situation, meaning that that bond is ionic, but I also have a covalent bond between my oxygen and my hydrogen. You'll see some of these in your homework packet for identifying bond types. A dead giveaway for a polyatomic ion that's involved is if you have 3 or more atoms present. So if I had like Na2CO3, I have a sodium, I have a carbon, I have an oxygen. That's 3 different elements. So chances are I'll have a polyatomic ion present here. And if I look at my polyatomic ion chart, I'll see CO3 in there, and that thing is called carbonate. So that's CO3, 2 negative. And then I have 2 sodiums, Na positive, Na positive. So my overall charge is 0, 2 positives, 2 negatives, and it all works out. That would be a combination of both ionic and covalent bonds. So you have an ionic bond between your sodiums and your carbonate, and then you have a covalent bond between the carbons and the oxygens seen here. Kind of neat.